right, we're going to go ahead and do the last part of our binomial lessons. And so first we want to kind of separate and clarify geometric versus binomial. And we'll clarify what we've done already and then talk about what we're going to learn today that is new and different. So we know that our geometric probabilities did this going until you have a first success. So we would then know that exact place of that first success. And so then that was our geometric PDF. So we're good with that. We also did talk about geometric CDF when we did that lesson 2 days ago. So we knew that first success was going to occur in a particular place or before that particular place, okay? So we covered those. Now, we did not cover this other part, and that's what we're going to talk about today in just a minute. Then yesterday, we talked about binomial PDF. So that was when we had a set number of trials. And so then we would say, okay, what's the probability of, say, exactly 2 people using the express checkout out of the 5 people? So we did that. Then we also, of course, a couple days ago when we did our geometric, we had that expected value and that standard deviation, which we also did yesterday with our formulas for binomial, the expected value and standard deviation, and we talked about that connection between the binomial and normal model. All right, so there's kind of a summary of what we've done up until this point with our discrete probabilities. So here we go. Now we want to talk about how would you handle a first success happening on or after a certain part. Okay? And I really think there may be 2 ways that we can think about that one. And so we'll talk about those 2 ways. Then also our binomial, we want to talk about these 2 situations. At least, at most, okay, less than, more than. Both of those kinds of things we will be accumulating. The problem is that our calculator has some limitations of how we can accumulate. Similar to how we did normal model stuff, we could only accumulate from the bottom part up to a certain point with our calculator. So that's going to happen here and cause us some limitations on that as well. So we'll talk about that and we'll look at that. Incidentally, some of the newer operating systems can go in between 2 values or can compute an area from a certain point up. So if you have one of those newer operating systems, you can play around with this, and then you might be able to have another option. But I'm going to go ahead and show work as if we have the older operating system that is more limited on its computing. All right, so now let's go ahead and go on back here to our problems on exactly, at most, and at least. So here we have our first problem. And we again have our, let's see, what is this? Our left-handed men again. Okay, so we've got our left-handed men, and we're going to go ahead and have probability of being left-handed 13%. What's the probability that out of 50 men, you get exactly 10 of them? All right, so you did that yesterday. So let's see you put that into play and work through that one. Exactly 10. Now I have this formula here for you so that you can see, and maybe then you can go ahead and work that out. We remember we want to show the work besides just putting it in our calculator. So here we have that 50 choose 10 successes. Our probability of success was 0.13 and we want 10 of those. So our failure probability was 0.87, and if we have 10 successes, how many failures do we have? Well, you know that 10 plus the other number totals to 50. So do you see here our success probability and the number of successes we have? Our failure probability and the number of failures we have. And of course, this is our 50 choose 10. Now, calculator-wise, here's how that computes out. All right, so here we go. We went and we put it into our calculator and did our binomial PDF. And we did our N out of 50, this probability of success, and I want 10 successes. Okay, so that came out to 5.39%. Now, don't forget that failures plus successes is the total N. So that's the safety net for you, okay? Failures plus the successes is that total N. All right, moving on. Let's see what happens now that is a little different. So here we're going to see what's the probability of finding at most a certain number of successes. So at most means a certain amount or less, okay? And so that ends up being a lot of work if we were to compute, say it was at most 10. Well, that would be 10 successes plus 9 successes plus 8 plus 6 successes, and so on. So that would be a lot of binomial PDFs to add up. So instead, we're going to use this cumulative feature to help us. All right, so let's see what that looks like. So here we have information we'll use the left-handed min. Find the probability that there is at most 15 out of a sample of 50. Okay, so let's see what we got here. So with at most, then I have to always think about this. If I want at most 15, can I have 15? And so that's yes. Okay, so at most 15 or less. So that's why I have this less than or equal to here. All right, now we have a sequence from 0 successes up to 50 successes. So do you remember how we would do that? We had this sequence, and so we have to show the work for 0 successes up to 15 successes. So in the sequence, we're going to have, no successes, plus dot, 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 plus, and then show the work for 15 successes. All right, so let's see how that sequence looks. You can try writing it down. If you wanted to pause, you could try it before I do that here. Here we go. No successes. 50, choose 0 successes. 13% are left-handed, and I want 0 successes, none of them. So the failure is 87. If there are 0 lefties, then there are 50 righties. And so that is our section for no successes. Okay, remember 50 plus 0 equals 50. Okay, now that's the first piece in our sequence. Now we do the plus, dot, 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 and then the plus. Plus, dot, 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 and then the plus. Okay, now show the top of our sequence, 15 successes. All right, so that's out of 50, we want 15 successes. What's the probability of success now? How many of those? We want, of the 13% success rate, we want 15 of those. So if we have 15 of those, how many failures do we have? Failure rate is 87.87, 35 of those. Again, because that failure rate plus the success rate totals to 50. The number of failures plus the number of successes totals to 50. Not the rate, but the total number. All right, so there is the work to show. Now we then can just let the calculator compute that for us. So calculator-wise, which you do not have to show, here is what happens. Our calculator will compute. So we can do binomial CDF, and it computes from the lower part up to a certain number of successes. It computes the lower area. So you start with your trials. Out of 50 trials, probability of success 0.13. I want the section I want is from 0 up to and including 15. So if you want up to and including, that's very important that you pay attention to this piece right here. Do you want to include 15 or should you just go 14 and below? This number is up to and including that number right there. Okay, so if I type that in, then that will give me my calculator of 0.9996. I didn't want to round that to 1. So I went ahead and had so many decimal places so as to not round that to 1. Okay, so that is your up to and including 15. So let's see what we got next. Let's do at least. All right, so here we go. If, say, I want to find the probability that there is at least 15 left-handed men in that sample of 50. Okay, so let's think at least. So at least 15. Okay, so I want 15 or 16 or 17 or so on. So I want all that 15 successes and above. Okay. So what that shows me is that here is what I'm wanting to calculate is success. I want greater than or equal to 15 successes. All right. So do your sequence. Let's do the first part of our sequence up to the last in our sequence. So if I were to type that out, I want 15 successes plus ... plus 50 successes. So I want all the way up. So there are the two parts of my sequence that I want. 15 successes up to 50 successes. So do those two parts of your sequence. Here we go. 15, choose, or 50, choose 15. See, that's the lowest part. All right. 0.13 is the success, and I want 15 of those. And if I want 15 of those, then how many failures do I have? 35, because 35 plus 15 is 50. All right, that's the first in my sequence. Plus, ... plus, here's the last in my sequence. 50, choose 50. So that is 50 left-handers and 0 righties. Okay, now, here's where it gets tricky. So, you know what though? If you actually happen to have a newer operating system, and I think it may even just be the Inspires that will do this, they will let you put a lower bound to an upper bound. So you could go from 15 up to 50. But our other calculators will not do that. They will only compute an accumulation from the bottom. So here's how we handle that. It's very tricky, but I have a technique that will work every time. So here it is. What we have to do, so since the older operating systems on the calculator cannot compute the upper probability, then it can only compute the accumulation of the lower probability. So we do this. We say to ourselves, what do we want? What do we want? So I write out the numbers just because I'm a very visual person. So I'm showing this to you concretely. You may eventually be able to think of this in your head, but I pretty much almost every single time, because sometimes it gets tricky on what exactly are you taking off or including. So I always write this out. And so you'll always see my work on that. Okay. So I do my sequence from 0 to 50. I start at 0. Once I get to this middle section here where I'm doing the transition of what I want to what I don't want, I write a few numbers. So I'll do like 14, 15, and 16. I'll usually do right around that number, 14, 15, and 16, and then all the way up to 50. Okay, then box in what you want. Well, I want 15 and above. So since I want 15 and above, that's what I boxed. But what I don't want is 14 and below. So see, look, what happens if the part that I don't want is what my calculator can give me? All that my calculator can do, my calculator only has the ability to compute that part that I don't want. So what am I going to do? Well, if that's the part I don't want, then I can just take 100% of the probability, cross out the part you don't want. So since I want the upper part, you can take away this bottom part, subtract it off from 100%. So what's 100%? That is 1 minus. So look down here. I'm going to do this 1 minus the bottom part that I do not want. 1 minus that bottom part that I do not want. And so what again do I not want? I want to take off 14 and below. I want to take off 14 and below. So see, that's why it's really important to pay attention to what are you crossing out? And I was crossing out 14 and below. So therefore, this number is 14, not 15. If you have a 15 right there, then you would be taking off 15 as well. And then you would just have 16 and above. Okay? So that's why I need this visual, because I need to make sure that I get this little section right and take off what I'm supposed to take off and leave what I'm supposed to leave. So that means that this is my work that I have calculated here. This is the work I have calculated, but I went and did this in my calculator, which you do not have to show, and that gave me that answer on my calculator. Okay? So there you go. That's how I did that. In fact, I'll show you that because, you could do it a couple of different ways. But if I open up my calculator, then I usually just go ahead straight away and I say, okay, I'm just going to do 1 minus, and then I'm going to go and calculate my binomial CDF. Okay, and I'm going to do 50, and that was 0.13. And I want to take off 14 and below. So see, I have that 1 minus that binomial CDF of those. And so then when I get that answer, that's my 0.0013 is what I had rounded it to, 0.13%. Okay, so let's move on. So that's as tricky as it gets. Okay, truly, that's as tricky as it gets. You just then have to be really careful with what do you take off and what do you keep. And if you write it down, then that's your foolproof way of making sure you get it. So here we go. Let's take a look here. What's the probability that you will get at most 14 tickets out of the 178 days of school? Now, you did decide that if you parked in the teacher parking lot, then you would get a ticket approximately 2 days of a week, so 2/5 of the time. So our probability of a ticket, 40% chance. So what's the probability you will get at most 14? So I want 14 successes or less out of 178. So what does your sequence include? So my sequence should include, and you can think about this to yourself, my sequence should include 0 successes plus dot, 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 plus 14 successes. Let's see, I want at most 14, so I want 14. Okay, so there's what I want. So make your sequence show that, and here it is. Do this intro. Probability that x is less than or equal to 14. So here I have 178, 0 successes, 40%, and I want 0 of those. So 0.6, that would leave 178 of those because remember that our failures plus our success is our total. Okay? All right, plus dot, dot, dot. The top, 14 successes is the top. So 178, 14 successes. That's 14 successes. Ooh, so this number here is 178 minus 14. So that's 164 failures plus the 14 successes is a total of 178. Okay? All right. So there's that. Now, computing. Okay? This is a bottom part. Our calculator can compute the bottom part. So I'm just going to go ahead and let it accumulate out of 178 trials. 0.14 is the success rate, and I want up to and including 14 successes. So there it goes. That came out to be 2.76 times 10 to the negative 22. Don't forget, if you get a number like 2.76, look at the end of the line because that's going to be probably a negative number. See, so if I was doing this real quick, let me just show you this because this is a common mistake that students will make. And it just can't be over 100%. So if I have 178.4 is my success rate, and I want up to and including 14. So here I go, and look at this answer. 2.76 should alarm you. You should go, what? 276%? No, look at the end of the line. Times 10 to the negative 22. So that is like basically a 0% chance that you're going to get 14 or less tickets. Okay, so you better save your money up because you're going to be spending a lot on tickets, or just don't park in the teacher's parking lot. Okay? All right. Well, but let's do this. Here we go. So I think we spend the rest of our time on this situation. So we've got this. The probability of being a smoker among the lung cancer patients. Okay, so the denominator is all the lung cancer patients. 60% of the lung cancer patients smoke. Okay, all right. What's the probability that a study with 152 patients has exactly 75 of them that are smokers? Exactly. Oh, exactly. That's our PDF, a particular number. So write out your binomial formula and do a binomial PDF. Okay? So here's what that looked like. You've got your 152 patients, and you want exactly, see, write out your intro, write it all out. 75 successes, success rate 0.60, and I want 75 of them. Okay? Well, then what's the failure rate? 0.40. Oh, well, how many of them would they be failures if 75 are successes? Well, because 75 plus what equals 152. So that's your rest of them. Okay, but then here's how it looked in my calculator. Particular, I want out of 152, 0.6 is my success rate, and I want exactly 75 of them. So just about a fifth of a percent, 0.19% chance that you'll have exactly 75. All right, so let's move on. Yeah, and don't forget to keep those numbers on the forefront of what did they actually mean. Don't get caught up in just plugging through the numbers. What does that number mean? Okay, what are you actually figuring out? All right, here we go. At most. So I'm going to let you, why don't you pause this video and you spend a little time practice showing your work and then seeing what you come up with on these next ones. See if you've got it down by now because I've gone through enough of these. All right, so pause and then we'll come back. All right, so here we go on this. We want at most 50. Okay, so at most 50, that means that we want 50 or less. So we can have 50. All right, so our sequence will go from 0 successes up to 50 successes. So 0 successes, 0.60, and 0 of them, 0.40, 152 of them, plus dot, 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 plus 50 successes, 0.60 to the 50, 0.40 to the 102 is the rest of them. So remember, our calculator can accumulate from the bottom. So that's 152.6 and 50. So there it is. So basically a 0% chance that 50 or less patients would have been smokers. So in real life, here's what that's saying. If you had a study and you went into this study thinking that about 60% of lung cancer patients are smokers, okay? But whenever you did your study and they were randomly selected, okay, when you did this random selection and you say got 48 that were smokers, then you're going to go, whoa, there was basically a 0% chance that we would have gotten that few of smokers if 60% is the real rate. So what that starts doing is this is big. This is what the medical research team says. They say, "Whoa, you know what? There less of them were smokers, but we still have this lung cancer rate, and so, less were being attributed to smoking. So something else is happening out there that is attributing to this lung cancer rate other than smoking. What's happening?" That's where medical research comes into play. That's where statistics is such a big deal. That's a weird amount. Why did that happen? What's going on? Okay. All right, let's see how you did on the next one. Oh, at least 85. So that's going to be 85 up to 152. So here is what your sequence looks like. But our calculator cannot compute the upper part. So we've got to do a little magic. So on these ones, I have to think. Okay, I write it out. I show what I want. Okay, so I go 0 up to 84, 85, 86, and then I go on up. Okay, so at least 85. So that's 85 and above. So I want 85 up, take off 85 and 80, take off 84 and below. Don't take off 85. If you take off 85, then you had at least 86. Don't take off the 85. Take off the 84 right here. Take off 84 and below. Do not take off the 85. Okay, so that's why it's important that you stop and think and make sure you get straight how much you're taking off. Okay, and then we'll finish this out. The last one, at least 100. Okay, so my sequence is going from 100 successes up to 152, at least 100. So I am taking off 99 and below. So then that's why my computing is going from 1 minus the bottom 99. I'm going to take off that bottom 99. Okay. All right, so there we have 8.38% chance that I would have 100 or more, okay? All right, so that's what's going on, and I think that may be all the practice. So here is, again, that summary. to help you kind of with that. See if you have less than or at most, then you can just binomial CDF the bottom part. But if you want more than, if you want a top part, more than or at least, then you need to do 1 minus the lower part. Okay? This happens here also for geometric. If you want your first success to happen somewhere after a certain place, then you can do it a couple of ways. One is take off the bottom part. All right, I think that is all that we got going on. And so then here is your, I guess this is your assignment. You don't do the 12 days of statistics yet, but here's a binomial and geometric probability practice. FYI, I have an additional practice that you could do if you needed to. So if you felt tomorrow that you needed additional help. Now we'll also be doing so to the after that you'll also be doing this one, which will mix everything all up, and that is this 12 days of statistics. So that'll be fun. We'll do that not tomorrow. Yeah, tomorrow. Okay, 12 days of statistics, see how you do on that, and then that puts it all together before our quiz over binomial and geometric probability. All right, good luck to you on the homework.